friends, in my last video we have studied about the hydrogen spectra. Today we are going to discuss about the spectra of sodium atom. We know the atomic number for sodium atom is 11. Its electronic configuration is given by 281, or we can write down 1s2, 2s2, 2p6, 3s1. If we see clearly or very neatly, we can see that the first 3 shows the electronic configuration of neon gas, which is an inert gas, plus 3s1 electron. If we talk about the spectra, then this s1 3s1 electron will contribute to generate the spectra for the sodium atom, because all these electrons are stable in their orbit. Now, for sodium atom spectra, the 3s state will act as a ground state. And to obtain the spectra, there are different selection rules. For this, it is delta L is equal to plus minus 1 is the selection rule to obtain the spectra of sodium atom. As we have studied in the hydrogen spectra, there are different series obtained. Same way, for the sodium spectra, we have to study different series. First one is the principal series. For the principal series, the transition is from NP state to 3s state. For the sharp series, the transition is from NS state to 3p state. And the diffuse series is obtained by the transition of an ND state to 3p state. For the fundamental series, the transition is from NF state to 3d state. Whereas for the principal series, the N value can start from the 3, because if we consider third orbit, there are 3s, 3p, 3d levels, correct? And for the 3p, the energy value is more than the 3s. So there are possibilities for the transition of a 3p to 3s state. Therefore, we have written N starts from 3, 4, 5. Now, for the sharp series, the transition is between NS to 3p, and the transition has to from S state. So we have considered the N starts from 4, 5, 6, because my 3s state is the ground state. So the transition has to be more. So it will start from 4s state for the sharp series. Similarly, for the diffuse series, the N can take value 3, 4, 5, because my 3d state is above 3p state. So the transition is possible from 3d to 3p state. For the fundamental, we know for the third orbit we don't have F state. So the transition is from 4f to 3d state. And this selection rule is delta L is equal to plus minus 1. Now we have to draw the spectra. Now when you draw the spectra, the transition or the electron which is in the 3s state will absorb energy and it will go to the excited state, such as 3p, 3d, 4s, 5s, like that. So when you want to draw the spectra for the sodium atom, along the vertical direction we have to draw the energy levels, right? Energy values. And along the horizontal direction we have to draw the orbits, as we have studied in the hydrogen spectra. So along vertical axis we have to draw energy levels, and we know how to find out energy values. For that also we have given one video which shows the relation between E and N. And horizontal, I will draw horizontal line which represent the orbit. Now the transition is between subshells, so we will draw S, P, D, F, and under this we will draw different orbits. For the 3s, this shows 3s, then leave some space because we have to draw 3p and 3d then this is 4s state, then we will draw 5s state, then 6s. Now for the P, when you want to draw 3p level, the energy value will be more than the 3s, so you have to show it. So you are diagrammatically, you have to represent that, because along vertical axis shows the energy level, so 3s and 3p will have certain relation of the energy value. The 3s and 3p level will have different energy levels. Same way for 4p, 5p, 6p. Next, we have to draw 3D. 4D, 5D, 6D. Now for the F, I know that for third orbit I can't draw F subshell, so I have to draw 4F, and we have to take care that the 4F, the energy value for the 4F will be less than 5S. Same way for 5F. Now, first series is the principal series. As we have seen that for the principal series, the transition is from NP state to 3S state. NP to 3S. For the principal, the transition for the principal series, the transition is from NP to 3S state. Right? So, and the selection rule is delta L is equal to plus minus 1. So I can draw the transition is from 3p to 3s, 4p to 3s, or 5p to 3s, and so on. Now we have to check whether the selection rule is satisfied or not. For 3p, L value for p orbit is 1. For s orbit, the L value is 0. The transition is from p to s, so delta L will be 1 minus 0, which is plus 1. Which is plus 1. So this transition fulfill the selection rule, so it is allowed transition. Now for the after principal, this series is principal series. Now, next is sharp series. For the sharp series, the transition is from NS to 3p. NS to 3p. 3p is here. S, NS, so we can't consider 3s, right? So we have to go for 4s. The transition will be from 4s to 3p. S to 3p. This is sharp series. Again we will check the selection rule whether it is going to satisfy or not. For S, the L is 0. For P, the L is 1. So the delta L will be minus 1, which satisfied the selection rule. So this transition is also allowed transition. Next is the diffuse series. For the diffuse series, the transition is from ND to 3P. ND to 3P. This shows the diffuse series. Now we will go ahead with the fundamental series. For the fundamental series, the transition is from, for the fundamental series, the transition is from ND for the fundamental series, the transition is from NF to 3D. NF. So the transition will be from 4F to 3D. We can take the transition from 5F to 3D. This shows fundamental series. Again we will check the selection rule. For D, the value of L is 2, and for F it is 3. So the transition is from F to D. So 3 minus 2 is plus 1, which is again fulfill the selection rule. So the transition from 4F to 3D is allowed transition, and due to this transition the fundamental series is obtained. So we have studied principal series where the transition is from NP to 3S state. Next we have seen the sharp series where the transition is from NS to 3P state. Next we have seen the diffuse series. The transition is from ND to 3P state. This gives diffuse series, where the transition is from ND state to 3P state. We can draw the transition from 5T to 3P also. The last one is the fundamental series where the transition is from NF state to 3D state. And for all these series we have checked the selection rule, which is given by delta L is equal to plus minus 1. I hope you understand clearly how to draw the spectra for the sodium atom. In this video we have seen the different series which are obtained for the sodium atom spectra and its selection rule. Thank you.